So given that ABCD is a parallelogram, we're going to set out to prove that angle A is congruent to angle C. And to help make this a little easier to talk about, I'm going to put some numbers in there, which is the same thing as to say angle 1 is congruent to angle 3. And that's all they tell us to start. So we have to bring everything else to the game. Before I go ahead and write my 2-column proof out, what I'm going to do is make some marks on my diagram and brainstorm a bit. It says it's a parallelogram. Well, we're trying to prove a property. So let's push all the properties out of the way, not touch those, but we can at least use the definition. What do I know about what is the definition of a parallelogram? It's what? Parallel sides. Okay. So if it's a parallelogram, I know that BC is parallel to AD, and that AB is parallel to CD. So I'll mark those on my diagram. Have I seen anything like that before with 2 parallel lines cut by a third? They're what? I heard someone say it. No, not perpendicular. Just ignore this part of the picture for a second. There's a transversal involved. So what do I know about angles 1 and 2? It's supplementary. Okay, but that may or may not be useful. I know it. What if I do this? I got 2 parallel lines cut by a transversal? Uh-huh. And don't we have a rule that says if 1 and 2 are supplementary and 2 and 3 are supplementary, that 1 and 3 better be congruent? Yeah. It's not a transitive property. I want to call it the supplementary angle theorem.
Wait, so don't all the angles have the same equal?
You know.
But then we do that.
We did do if we do the diagonals. They have the same midpoint. I haven't drawn the diagonals yet. We could also just reprove that too. If you don't remember the supplemental angles theorem, the one that says if 1 and 2 are supplementary and 2 and 3 are supplementary, then 1 and 3 are congruent, you can reprove it. These guys add to 180. These add to 180. Set them equal and subtract off the common guy, and you get 1 congruent to 3. And if you really think about it, that's not that many steps either. But the key to it, why again, if I said it once, I've said it at least 3 times this year, you got to memorize these rules because they help. They help get through this, as long as you remember what you're going after. So let's write our 2-column proof now. Statements, justifications. We start off by saying that ABCD is a parallelogram. And that is by the, well, that's given. Then we said that there's a definition of parallelogram involved. Definition of parallelogram. And that told me that BC was parallel to AD and that AB is parallel to CD. And having got that into play, anyway, what was the rule again that we used with 1 and 2? They're supplementary, okay? Angle 1 and angle 2 are supplementary. And while I'm at it, I'm going to write down 2 and 3 are. What rule says that I can do that, though? Now that's later. I've got parallel lines, therefore I've got these angles are supplementary. What kinds of angles are they? Same side interior angles. Now I can use the supplementary angles theorem to say, hey, angle 1 must be congruent to angle 3. It's like transitive. Because that's the one that says if 1 is congruent to 2 and 2 is congruent to 3, then 1 is congruent to 3. So it's similar, but it's not quite the same. This is one of the first theorems we did, if you remember, way back when. These guys add to 180, they add to 180, subtract off the extra, you get that. And that's, I believe, what I set out to prove. What's up? But yeah, that might not hurt to say it if it helps organize your thoughts. If you want to write in there that that AB is transversal, and that's by definition, to help organize what you're thinking of and how you're picturing it, yeah, you can write that down. There's nothing wrong with a few extra steps, just as long as you still get from point A to point B. And also be able to be on the lookout for when to use either the right theorem or what that theorem is cueing you to do. If I were to put this on Friday's quiz, would I put that on Friday's quiz? If it was open note, I would. If I put something like this on the quiz and it's not open note, I might just give you that.
No, could you give us that statement?
And you come up with the justifications?
Yeah.
I could do that too. And so it's easier this way? Give you the justifications and you figure out how to match it up? Well, here's the nice thing about doing it this way. If I give you those, I really need to get a manicure. If I give you that, you can say, well, I know this. Well, what does the definition tell me? Okay. Well, given that definition, what can I do with same side interior angles? Where does that lead me? Oh, supplementary angles there. Where does that lead me? It kind of helps map the road a little better. Whereas this way, okay, I know where I'm going, but now it's just a matter of how do I get there?